Hey guys, welcome to another exciting day of transformations. This time we're going to do transformations of quadratic functions, which is section 2.1. And these rules are going to look familiar to you because we did them with absolute value. That's the cool thing, is the same rules apply to every function. One piece of advice, I do my videos all in one piece. I don't split them up. So if you're getting sick of listening to me talk, not sure why you would, but if you are, you can always just pause the video so that it's not too overwhelming. Okay guys, so here are our notes right here. I want to quickly remind you what this A, B, H, and K thing is. Before we did this with absolute value, so notice it's a little different this time. Instead of absolute value, we now have this quantity squared, right? Because a quadratic is squared. So the parent function of a quadratic is y equals x squared. Now notice these are the same values we did for the x values for the absolute value function, only this time if I take -2 and plug it in for x, I don't get absolute value here, I'm doing squared. So -2 out pops 4 for y. So this is what we end up with if we punch all those x values into our function. So let's just a quick reminder. Here, if we start putting extra stuff on it, right, an A in the front, a B inside, an H inside, or a K outside, I want to remind you guys that A and K affect the Y, the parent Y values. So anything in black here affects the Y value. So let's remind ourselves with A, if I have an A in front, that's going to give me either vertical stretch or compression. So what do I do in my table? Well, in my table, I'm going to multiply the parent y values by A. Right? So if A is 2, I'm going to come over here and multiply all my parent y values by 2. Another thing that changes the parent y values is the k. So this is a vertical shift, right? So a vertical shift can either mean up or down. So what I'm going to do is I'm going to add k to the parent y values. So notice both the A and the K, which are outside the function, not in there with the X, affect the Y value. So what affects the X value? Well, the B and the H. So the B, if you remember, is a little strange. This is horizontal stretch or compression. And what it does is it's going to multiply. Remember, inside the function affects x. It's going to multiply the parent x values by the reciprocal of b. I think that's the trickiest part, right? We're going to do whatever a b value, I'm going to flip it over, and that's what I'm going to multiply my parent x values by. Okay, H is also inside the function, right guys? So this is our horizontal shift. So the horizontal shift means I'm going to add H to the parent X values. So what I do when I see an equation, they tell me graph it, I identify, okay, what have I got here? Do I have an A, a B, an H, a K, or any combination thereof? One thing I really want to point out that's important, guys, this middle value right here is at H, K, and it is called the vertex. So I can look at my table, or I can look at my equation, and I'll be able to see what the vertex is. The vertex is at H, K, and it's the middle value in the table. Okay, so let's try our first graphing problem. What if someone wants me to graph y equals x minus 2 quantity squared minus 3? Well, let me see. Do I have an A? Well, I don't see an A out here. It's just 1, right? And I don't have a B either here. right? I don't have anything in front of the x as a coefficient. But I do have an h and a k. So my h equals 2 and my k equals -3. Now some of you may be saying, why is it positive 2, Miss Brinley? It says -2 there. But take a look, guys. I want to remind you real fast. Look at how the equation is. It's x minus h. So if it says x minus 2, that actually means that positive 2 is h. A little bit tricky. So just knowing this, guys, where is my vertex going to be? Well, my vertex is going to be at 2, -3. So let's just put that right in here. Okay, so what we can do here, guys, we've got an h and a k. So let's check and see what the h does. The h says we are going to add h to all the parent x values. Okay, so here are our parent x values. So if I'm going to add h, what I like to do is put like a little formula here. So here are my parent values, -2, -1, 0, 1, and 2. So I'm just going to add 2 to each of these. Right, because that's what my h tells me. So -2 plus 2 is 0. That's 1, that's 3, and that's 4. Okay, guys, so we've got an h. We also have a k. And our k is -3. It says add k to all the parent y values. Well, I'm going to put all the parent y values here. And now let's add k, or in other words, add a -3 to all of these. And then we will have something we can graph. Okay, guys, let's graph this. Okay, so let's see what we've got going here. So it looks like since we didn't have an A or B, we didn't have any stretching or compressing. All we did was shift. We just shifted 2 to the right and 3 down. And then lo and behold, guys, here's our new vertex. Right? We shifted 2 units right and 3 down. Our parent graph has a vertex of 0, 0, so we move to the right 2 and down 3. Okay, let's spice it up a little. Let's put some A and B going on in there. So here it looks like I got all of them. I got A, I got B, I got H, and I got K. Sorry, this should say Y minus 3. Okay, guys, so let's take our parent values. I'm just going to recopy the Y parent values. Oh, I didn't leave a lot of room here, did I? I'm going to recopy the Y parent values right here. And they're 4, 1, 0, 1, and 4. So let's see, what affects the Y? Well, A affects the Y, and K affects the Y. So if I had to describe in words what I'm going to be doing to the Y parent values, I'm going to be multiplying them by -2 and then adding 4. So watch what I'm going to do here. -2y plus 4. And I'm going to put a little p down there that means parent. So that means I'm going to take all my parent values, multiply them by -2, and add 4. Okay, so let's see what we get. -2 times -4 is -8. -8 plus 4 is -4. -2 times -1, so I'm just going to fill these in. That's my new Y table right there. once I do my transformation, negative 2 times the y parent plus 4. Okay, what about the x? So notice, I'm going to put this in red, hopefully it'll show up. This is my b value and my h value. So my b value here is 2, and my h value here is negative 1. Remember it says plus 1, but it's the opposite. So if I'm going to write myself a little formula, what will I be doing to the parent x values? First, let me write down the parent x values. Negative 2, negative 1, 0, 1, and 2. Well, it looks like I'm going to be multiplying them not by b, but by the reciprocal of b. So I'm going to be multiplying each of the x parent values by 1/2. And then I'm going to be adding a negative 1. So I'm going to be doing 1/2 x parent times negative 1. So let's just write that in here. 1/2 x parent minus 1. 1/2 x parent minus 1. Okay, so let's see what we get here. Well, 1/2 times negative 2 is negative 1, right? And negative 1 minus 1 is negative 2. And I'm going to see a pattern here pretty soon. 1/2 times negative 1 is negative 1/2. Minus 1 is negative 1 and 1/2. 1/2 times 0, 0. Okay, guys, I'm hoping you see the pattern here. It's plus 1/2 each way, right? Each step is plus 1/2. So let's graph this. Let's see what it looks like when we graph it. And then we're going to describe the transformations, which are definitely a little bit more substantial here. Okay, so look at this. This is a super tall and skinny parabola. So let's think about, why is it tall and skinny? Well, let's look here. First of all, you may notice it's upside down. So the first thing we're going to say is there is a reflection across the x-axis, That's what the negative does. That's what this does right here. Okay, what about the 2? The 2 says, the 2 on the outside right here, there is a vertical stretch by a factor of 2. Okay, that's the 2 right here. What about this 2, guys? Well, it looks like, what did we do to our parent? Well, we didn't multiply it by 2, we actually multiplied it by 1/2. And multiplying it by 1/2 makes it smaller. So we're going to say it's a horizontal compression by a factor of 1/2. So what I look at to decide what I'm going to call my compression or stretch is I look at the value I actually multiply by. Guys, does that explain why it's so tall and skinny? Because think of it this way. If I vertically stretch something, right? I'm making it taller. So this has a vertical stretch, but it also has a horizontal compression, like an accordion. So both of these, the vertical stretch and the horizontal compression, act in unison to make it super thin and tall. So it's like we've got double whammy tallness factor going on here. Okay, our last thing is now our vertex is over here, right guys? Here's our new vertex. That's the vertex. So the way we'll describe that is we'll say shift left 1 unit and up 4 units. So we have all of the transformations going on in that problem. Okay guys, I'm going to move over to the other boards. Meet you over there. Okay guys, so on the first 2 examples, we actually had an equation and we made a graph. Now we're going to be given either a description or a graph, and we're going to be asked to write the equation. So here's the super duper Brindley method that I use. I know for a fact that this is a quadratic because it says it wants transformation from the parent y equals x squared. So watch what I do. I draw myself a little shell. And the reason I do that is there's a lot going on in this problem, and I really don't, if I think of too many things at once, I'm going to make myself stressed. So let's just go step by step. I have a vertical stretch by a factor of 4. So a vertical stretch goes out here. So I'm going to put that 4 right there. What's next? It says I have a horizontal compression by a factor of 1/5. Okay, so if I've got a compression by a factor of 1/5, what shows up in my equation is actually a 5. Not a 1/5, it's that reciprocal thing. Okay, then they tell me I have a reflection across the x-axis. Reflection across the x-axis means there's going to be a negative sign out here. And last but not least, they tell me there's a translation. Translation is just another word for shift. 3 units right, so that's going to become x. Okay, guys, we're tempted to put plus 3, but it's actually minus 3. And then 6 units up becomes plus 6. So there's our equation given that description. Now on B and C, they tell me assume all stretch or compression is vertical. So that means there is no B value. Not on these. So we're not going to have a B value when I'm asking you to recognize a stretch or compression. So here's our parent, y equals x squared, right? Notice the vertex here is at 0, 0. So where's my new vertex? Let's label it. Well, it looks like it's at 1, 2, -4, comma, -1. So again, I'm going to write my little shell here. Y equals something squared like that, right? So if my new vertex is at -4, -1, that's going to mean x plus 4 minus 1. Okay? So now what I like to do is I like to check if there's any compression or stretch. Well, if I see this, let's label these 2 points, but guys, because your graph may not be quite as visible as mine. This is at -5, -2, and this is at -3, -2. So it doesn't look like I have any stretch or compression, right? Because the parent, I go over 1 and then up 1, and that gets me to my 2 points that are closest to the vertex. Same here, over 1, but instead it's down 1, right guys? So it's upside down, so that means there's a negative sign out there. That's how I'm going to be able to tell. Okay guys, last one of these. Here's my parent. Let's find our new vertex. So I'm labeling the vertex here 3, 2. So again, I'm going to write down here something x squared. My new vertex is at 3, 2. So that means I'm going to get x minus 3 squared plus 2. Okay? Do I see any upside down? No, right? It's right side up, so that's not going to be a negative. But let's compare here. Instead of over 1, up 1, which is the parent, what have I done here? I've gone over 1 from 3 to 4, and I've gone up 1/2 from 2 to 2.5. So that means I've got a 1/2 out there. That's a little tricky. So if you want to pause or rewind and watch that again, I've gone from 2 to 2.5, so that's actually a 1/2 instead of a 1, which means it's compressed by 1/2. Okay guys, our grand finale. Our grand finale is a word problem. terrible one,